Hello and welcome to Polarity of Bonds with Dr. Kim. I'm going to attempt to explain the difference between polar and nonpolar bonds in this video at the level of Chem 130 students at GCC. When we talk about polar and nonpolar bonds, we are talking about covalent bonds only, not ionic. We're only talking about covalent bonds being polar and nonpolar. Now, if you remember, a covalent bond is between what and what put together? Hopefully you said nonmetals. That is correct. It is a nonmetal plus a nonmetal bond. That's what covalent is. Now, covalent can be described as either polar or nonpolar. The word polar means poles, like two ends of a magnet. Magnets have a plus end and a negative end. That gives them two poles, so magnets are polar. Covalent bonds can be polar as well. They can have one end a little bit plus and one end a little bit minus, making two poles of the bond, making it polar, just like a magnet. I'm going to start with what is nonpolar first, however. Nonpolar means no poles. Let's imagine an atom bonded to itself, sharing electrons. Now, if you're bonded to yourself, those electrons are right in the middle. The electrons are in the middle because you're bonded to yourself. See, all atoms have the ability to pull electrons towards them. That's called electronegativity. Electronegativity. This is often abbreviated EN. What is electronegativity? Well, it's the ability of an atom to pull bonded electrons close. So it's kind of like a tug-of-war. Who can pull the electrons closest? So electronegativity actually increases in the table up and over to the right, except not our noble gases. Why don't the noble gases have an electronegativity? Why aren't they included? There's your clue. Because they don't have bonds. So noble gases don't have an electronegativity because they don't have bonded electrons. So let's look. Who is the most up and to the right, excluding the noble gases? Well, fluorine. Fluorine is the most electronegative element. It pulls electrons closer than anybody else. And the closer you are to fluorine, the better you pull electrons. So let's remember that. Fluorine pulls electrons closer than anyone else. In a covalent bond, of course. So back to our nonpolar. If you're having a tug-of-war with yourself, no one wins. The electrons are right in the middle. So we don't have electrons close to one side. They're right in the middle. There's one other bond that's going to be nonpolar, and that is between carbon and hydrogen. They basically have the same electronegativity between carbon and hydrogen. So the electrons are also in the middle. So we don't have poles. Carbon and hydrogen is a nonpolar bond. So now let's examine the polar bond. So let's say we are bonded to something different, X and Y, two different nonmetals. One of them is going to have greater electronegativity, which means they're going to pull the bonded electrons closer. Let's say X is that one. It has the higher electronegativity, so the electrons are closer to it. What's the charge for electrons? Negative. So if electrons are really close to X atom, that's going to make it a little bit negative. Okay, what did I just draw there? That's a delta. Looks like a figure 8, but you don't finish it, and it means a little bit. A little bit positive or a little bit negative. Because the electrons are negative, that makes X a little bit negative. So by default, what is Y? You're correct if you said a little bit positive. So the electrons are closer to X, meaning the negative charge is closer to X, so it's a little bit negative. By default, Y is a little bit positive. Guess what? We have poles. We have two poles, just like a magnet. So polar, because we have poles, just like a magnet. So two different non-metals, because of course we're talking about covalent bonds, two different non-metals are going to be polar. One's going to be more negative than the other. So we have, it's like a little magnet. So it's a polar bond. Let's look at some examples. P to Cl, F to S, O to H, C to O. These are four bonds that are covalent because we have non-metal to non-metal. Let's look at these bonds and see who is a little bit negative and who is a little bit positive. The first bond is P and Cl. Here's P, here's Cl. Who's closer to fluorine? The Cl is. This makes the Cl a little bit negative and the P a little bit positive. You know, there's a second way to show polarity, and that's by drawing the polarity arrow. The arrow is drawn to point towards the negative, and you cross the end that's positive. So this arrow is a polarity arrow. It also indicates that PCl is a polar bond, this side being a little bit negative, and this side plus a little bit plus. Now F to S. Here's sulfur, here's fluorine. Who's closer to fluorine? Well, that was kind of a silly question because of course it's fluorine, making fluorine a little bit minus, sulfur a little bit plus. Which way does the arrow point? To the F, and we cross the positive. Okay, what about O and H? Here's O. Where's H for electronegativity? We said C and H are about the same. So we can think of H as being here. Who's closer? Well, the O. The O is closer. That makes the O a little bit negative and the H a little bit positive. Which way does the arrow point? It points towards the O, and we cross the positive. Last one, CO. Here's C, here's O. Who's closer to fluorine? The O is. So the O is a little bit negative, C is a little bit positive, and the arrow points towards the O, and we cross the positive. I'm going to do one more. C to H. We said C is here. Where's H? Well, we said the electronegativities are about the same, so H is here. Which is closer to fluorine? Wait a minute. They're the same. So we can't do deltas on the CH bond. It is non-polar. So do not put deltas or the arrow on the CH bond ever. It doesn't get an arrow. It doesn't get deltas. It's non-polar. Don't be tricked by that. So to summarize, covalent bonds can be polar or nonpolar. If you are bonded to yourself, like Cl to Cl, O to O, H to H, Br to Br, you have electrons in the middle, so you don't have poles. C to H also has electronegativities about the same, no poles, nonpolar. If you are bonded to someone different, then you're going to have two poles. And whoever's closest to fluorine gets the little bit minus, the other atom's a little bit plus. You're like a little magnet, you are polar. I hope this has helped clarify for you what polar and nonpolar bonds mean. Good luck.